Note the phrase at least means greater than or equal to, and you can use the complement rule. So let's look at an example. The probability that a randomly selected female aged 60 years will survive the year is 0.99186. What is the probability that at least one of the 500 randomly selected 60-year-old females will die during the course of a year? So we're looking for the probability at least one dies. If we use the complement rule, that's 1 minus the probability that none die. We know the probability of not dying is 0.99186. And how many do we have that are going to be surviving? That's 500. So we raise it to the 500. We get 1 minus 0.0168. This is equal to 0.9832. So if we want to interpret this, we could say if we randomly select (500) females, 60 years of age, 1,000 different times, we would expect at least one to die in 983 of the samples. Okay, because again, we're looking for the probability that at least one dies, and that's 0.9832. So below are the summary of the rules that we have learned in this chapter. Rule 1 is that the probability of any event must be between 0 and 1. Rule 2, that the probabilities have to add up to 1. If you are working with disjoint or dependent events, you're going to just add them together. If they are independent events or not disjoint, you're going to add them together and then subtract what they have in common. E to the C represents a complement. Here's the formula for that. And then what you learned in 5.2 is right here. If E and F are independent events, then the probability of E and F equals the probability E times the probability of F. Notice that our OR probabilities use the addition rule, so we're adding, whereas the AND probability uses the multiplication rule. Accordingly, OR probabilities imply addition, whereas AND probabilities imply multiplication. As the end of this lesson, please let me know if you have any questions.